Hello again, you sick, twisted weather freaks and snowstorm perverts over the eastern U.S. Welcome to another fun-filled, action-packed, and intellectually stimulating edition of the Snowstorm Podcast. It's Saturday. It's March 17th. It's St. Patrick's Day. Happy St. Patrick's Day to you all, and of course to the Irish, who I just happen to love, along with the Scots. I am meteorologist DT, your professional evil scientist from weatherrisk.com. A lot to talk about here, and a very complicated, interesting situation, so let's get right to it. First, we're going to start out with a little local radar. And here's the radar here from this afternoon, about noontime, and you can see we've got some snow in the northern Shenandoah Valley up into Winchester and portions of the, I guess that's the northeast Virginia panhandle there, Martinsburg, and then up into western Maryland. Not a surprise. And then north of Richmond, some pretty decent rain here, but south of Richmond, it's just overcast. So if you're getting snow in this area, it's going to continue here probably till about 2 or 3 in the afternoon, I would think, in this whole area. Here's the western edge of it out by Morgantown. So mostly looks like it's going to pass just to the north of D.C. So it's not sticking, but it is snowing. So not a huge surprise. Now, let me show you some differences of what's going on here. This was February, and these are the temperature anomalies, departure from normal. And in case you can't read the scale here, and judging by the viewer email and some of the comments, some people can't, you can see here in Virginia, for example, right here, 6 degrees above normal. In the Carolinas, the red is 9 degrees above normal. In New England, it's a lot of areas 6 to 8, 7 degrees above normal. Also in Ohio, very warm February, as we all know. But then, of course, the pattern began to change, and we can see the differences dramatically here. This is the upper left. We have this is for the first half of the month. You can see it's been quite cold, and this the dark green stuff is 2 degrees, 4 degrees below normal. The blue stuff is 4 to 6 degrees below normal in much of Virginia, and then North Carolina. Now remember, this is March, so your daily temperatures are going up every day. So the same air mass in February, which would be, let's say, normal temperatures, is actually going to produce below or much below normal temperature anomalies in March. And we can see the effect of that. Notice that in New England, temperatures are not running below normal in New England here at all. You can see that. That's because one of the reasons is because our temperature anomalies are still quite cold in March. So there's the difference right there. So, but if we look over the last week here up to the 16th, you can see brutally temperature anomalies all of this area. -8, -10 degrees below normal. Are you kidding me? Where is spring? Even southern New England has had below normal temperatures into New York City of 2 degrees below normal there. So yeah, there's no sign of spring at all, as we can see here. Now, what exactly is going on? This is the change in the pattern here. Now, this is the upper air map. We can see 500 millibars. This is from March 3rd. This is the block, which was caused by, and partly caused by the southern stratospheric warming, which took place in late February, and it caused this huge block to form. Now, this block originally came over from England and the United Kingdom and Iceland, and it came in this way. And then you can see now this is this tip right here. That's Greenland, in case you can't see it, and this is eastern Canada here. This is Quebec and Labrador. So you can see this huge block positive anomaly, and that started showing up in the beginning of March, late February, when it started turning colder. And we can see how this has progressed. The upper left, we can see this is March 8th, and this is March 12th. And here's the block still. You can see it, positive anomaly right there. And what it does is it's forcing the jet stream to come southward with these weather systems. So you can see this is the beginning of the last big storm they had in New England, the one on March 8th and 9th. And here's the other one that came in last week. So you can see it. And of course, now we have this much bigger ridge on the west coast. What happens is that once this feature moves into place, this begins to back up because the flow begins to buckle. So in other words, normally what you're looking at is you want to see the typical jet stream goes west to east like this, right across the country. But when you start getting this block forming here and things start going underneath it, you start getting a ridge popping this way. So the block does a lot of damage and does a lot of things to the overall pattern. Now, this is March 14th, and we can see this is from last couple of days ago. This was the last storm which brought the snow to New England, the blizzard conditions and light to moderate snow in southwestern and central Virginia, northwest North Carolina. But screwed over Washington, Baltimore, Philly, and New York. And there's our block here. You can still see it very pronounced, and a strong ridge here. And there's the next trough coming into the west coast. So that was the pattern on March 14th. All right, let's move on. Now, This is our teleconnections map when I want to show this briefly. Now this is of course on the website, and this is a nice schematic. This is the area which focuses on the NAO. And of course for the winter snowstorms you want to see the negative NAO. You want to see that. Now this here is the Arctic oscillation. Up here in the North Pole, in the Arctic region, we want to see a negative Arctic oscillation. The P&A pattern, you want to see this is positive. You want to see the positive one. Now remember, each one of these can go positive or negative. Now this map has all the correct symbols for the big snowstorm, but it doesn't necessarily have to be that way. This is just a schematic. And of course, over here is the Eastern Pacific oscillation here, and typically you want to see that negative. So this is what you want to see for a big snowstorm on the East Coast, and you want to see a big 50-50 low, which is a big low in the upper atmosphere over southeastern Canada, 50 degrees north latitude, 50 degrees west longitude. That's what you classically want to see for the big snowstorm. Now let's take a look at our teleconnections. Now these have changed a little bit since last time. Looked earlier, we could see that on the Arctic oscillation here, it was going up March 20th. This is when the next event's coming in, so we have a phase change here from negative to positive, and then it looked like it was going to stay positive, but then you look what happens. The new data shows it going neutral. This here is the NAO, and it goes negative, positive phase change right in here from negative to positive, then it drops back down again, stays neutral. So that's a bit of a change. That's not what was showing earlier. This is indicating maybe more cold pattern coming up. Now this is on the Pacific side. Okay, so this is the Eastern Pacific oscillation and the P&A. Again, this is the Pacific side here. These two are the Pacific ones. All right, good. Let's go back. And then we can see the Eastern Pacific oscillation strongly negative, very negative now, goes up a little bit neutral, then it goes back down again. And the P&A pattern, it gets close to neutral here, and then drops back down to negative again. So the Eastern Pacific oscillation is very strong for the cold signal here. The P&A is neutral. Let's take a look at that again, and you can see what the conditions are. So we have the P&A is neutral. Okay, so that's not great. And that's neutral. That's great. Arctic oscillation is neutral, and the NAO is neutral. So it's not horrible, but it's not perfect for the big East Coast snowstorm. Okay, let's move on. It looks like there's going to be two systems here, folks. Two pieces of energy called short waves. That's what we call them in the weather business. That will generate two separate low pressure areas. The second one, if it's cold enough and close enough, could bring more snow than the first one. So let's take a look at this in more detail. Now this here is the early morning Saturday Canadian. And here is the first system. And you can see this is all rain. Okay, the only people that see snow is the northern end of the Shenandoah Valley up to DC, maybe DC. But definitely the northern Shenandoah Valley, western Maryland, southern Pennsylvania. Here's the first low. There's the primary there, the second low. Now moves off the coast. We have one low right here. You can see it. One low. Sorry about that. And again, look at the snow line. It comes south a little bit. Northern Virginia is getting a decent little snow. DC, Baltimore, Charlottesville, Stroudsburg, Front Royal, Winchester, the whole thing. Yep. So that's fine. And then we can see, let me clear this out here. Yeah. There we go. And then we go to the next slide, and this is where it looks, finally, the low moves off the coast. And we have a little bit of light snow here on the 21st in the morning to midday hours over western and central Virginia, even into northwestern North Carolina again. And what does that do for snowfall? Now, because the Canadian model has this low further off the coast, look where it is, it's out here, the snow is not that much in this area, it's light snow. And that makes a difference for the snow accumulations. And you can see the Canadian does not have much snow accumulations in this area, as you can see. All the snow is in northwest North Carolina, western Virginia, and the big snow is the eastern half of West Virginia, northwest Virginia, again, north of Charlottesville, all the northern Piedmont, into DC, Baltimore, southern New Jersey, and up into western Maryland. That's a very viable solution. That could very easily be the case. Let's take a look at what's going on in the upper area pattern. Now, this is the GFS from early this morning. All right, so this is the 0Z Saturday GFS. We'll look at this one first. There's the short wave. That's the feature we're looking at right here. And this is valid Monday evening at 8 p.m. All right, so far so good. Now look what it does here. Let me, oops, clear it out. Now here is the model data. This is, again, the 0Z GFS. This is Tuesday afternoon and then again on Wednesday. So the lead short wave is here. Right here. And this is second piece right there. See that second piece? Bada boom, bada bing. Now, this piece goes bye-bye off the coast. Okay, that's fine. Then this piece moves to the southeastern coast. And look, we have a little negative tilt here. Yeah, that's very interesting. And that allows the second low to develop. But is it going to develop close enough to the coast? It might be a miss. That's the issue. So let's take a look. See, now here's the GFS. I've enlarged this a little bit. So here's the first low. And again, most of Virginia is rain. Most of West Virginia is rain. All of North Carolina is rain. A good portion of Maryland is rain. But the northwest area of Virginia and the high elevations, the southern Pennsylvania, get hit with the good snow in the first system. And here it is moving off the coast. Again, snow close to D.C., northern Virginia, Martinsburg, the northeast panhandle of West Virginia, southern Pennsylvania, up to New York City, New Jersey. Philly could get slammed on here in South Jersey. They could get a good snow out of this, potentially, on the 0Z GFS. And now here's the second low. Okay, there's the second low. See where it develops? Here. See that? And of course, it pulls the cold air southward, and we're getting the snow begins to drop into the Shenandoah Valley. And then everybody in Virginia, Maryland, West Virginia is getting some snow here. And the low is here, off the coast. And this is the 21st, the morning of the 21st. So this comes in at nighttime, which is also good for March snowstorms. You want them coming in at night. So what does that mean for the snow mounts? Well, here's the GFS. It's got everything, as you can see, very stratified snow. Pretty much that's the Pennsylvania Turnpike, a little north of that. But as you can see, it's south of Allentown, but Philly gets several inches of snow. Baltimore, the northern, there's West Virginia does very well. Southern, western, and central Maryland does well. Now, for some reason, it's got a gap in D.C. around 2 inches. I know, given what D.C.'s happened, that wouldn't surprise me if that was the case. And then it's got the second area of snow down in this area. So Roanoke, Lexington, Lynchburg, Richmond, Northern Neck, Salisbury, Dover, up south of the D.C., maybe Manassas, Warrington, that sort of thing, a few inches here. Now, this is again includes sleet, and it's a 10-to-1 ratio. So this may be overdone, but definitely 2 areas of snow here, according to the GFS. Now, let's take a look at the European. Now, the European is the same sort of thing. Here's the shortwave at 60 hours. You can see it very clearly here. Let me highlight it. You can see the feature I'm talking about. There it is. Very strong piece of energy. And this is at 72 hours. Now that, let's go back to the GFS. Okay? Here, very similar features. There it is. Now the northern branch is a little stronger on the European. You see how much stronger it is here? You can see all the lines here all packed up. This is a little stronger, bringing the cold air in. But there's a feature at 60 hours. Now what happens at 84 and 96 hours, what happens is, okay, the main shortwave, the first one, here it is, okay, through Virginia, going off the coast. There's the second one. And look what it does. It now goes down here. It's neutrally tilted, but look how far south it is. I mean, it's really far south. And there's that northern branch really bringing the energy and the cold air in, but it's really keeping this feature way to the south. So, you know, in that sort of setup, there's going to be no north trend if that's correct. I know people want to talk about a north trend, but this is not happening on any of the model data that I'm seeing so far. Now, if we go to here, this is 108 hours, and there's a shortwave flying off the coast. Notice it's not as amplified, negatively tilted, but it's not as amplified or as strong as it is on the GFS. And as a result, the European has the second low. The surface low develops much differently. So let's compare that to this. This is the 12Z run. This was on Thursday afternoon. This is 12Z Thursday. See how much different this is? See how much bigger this is? That's a much bigger low here. Now, but again, this is now the 0Z run. That to that. That, the new run, old run. New run, old run. Big differences. Now, the surface map, here's the European. Okay, Monday, the 19th is rain, everybody. A little bit of snow developing in the Shenandoah Valley. And then here, boom! Big snowstorm, D.C., moderate snow in D.C., Baltimore. Southern Maryland gets hit. Fredericksburg, Stratford getting slammed. Much of the Piedmont, the Shenandoah Valley, all of it. The eastern panhandle of West Virginia. Maybe down to Roanoke. Maybe. More like Lexington, I would guess. Richmond's mostly rain. All of Hampton Roads is rain. Southeastern Virginia's rain. Norfolk's rain. North Carolina's rain. And if you go beyond that, then the low moves off the coast. And notice what happens, but as low moves off the coast, the precipitation becomes lighter. It's also in the afternoon. This is now 2 o'clock in the afternoon. So a lot of this precipitation, this is 2 o'clock, has gone over to rain here, or rain-snow mixed. Now this, remember, occurs, look at the time frame here. This is Monday night into Tuesday morning. This is nighttime, there's your snow. Nighttime snowstorms in March. And of course, this is the second low. Now remember how we talked about the upper air energy was handled much differently here on the early Saturday morning European. That's why the surface low is weaker, and the second snow is also much weaker over Virginia and North Carolina. Now this is the new NAM, which just came out, the 12Z NAM, and you can see here that it has, there's the main first piece of energy, there's another one back in here. So we see what happens here as we go into 84 hours. So we have the second piece of energy, looks very strong now on the NAM right here, and the other piece of energy is this one. So does this mean that the second low is going to be closer to the coast? Maybe, I don't know. We'll have to see what the new data shows later on when it comes out. There may be some changes in that coming up, so we'll have to wait and see. So, and this is the NAM surface map. This is the first low. Again, look at the snow over northwest Virginia. Most of Virginia is rain on the first low. DC's probably rain. I think Baltimore, all of eastern Maryland, Delaware, all of Virginia, so on and so forth. Southern Pennsylvania is snow, and so on and so forth. So that's probably where the correct solution. But again, where's the second low? Is the second piece of energy going to be closer to the coast? Is it going to slide off the coast? These are all questions we're going to have to look at during the day today, and I'll issue a new update on the Facebook page around 4 or 5 o'clock this afternoon. So this is meteorologist DT from weatherist.com. I'll see you on the Facebook page and on the Twitter page.